AI Think Tank podcast, the future of intelligent systems, machine learning, and data science. I'm Dan Wilson, coming to you from Seattle, Washington. Today, we're joined by Jerry Yurchisin, senior data scientist at Gurobi. With over a decade of experience in operations research, data science, and advanced analytics, Jerry has helped government and enterprise teams make better decisions through customized optimization models, applied machine learning, and simulation. His work bridges the gap between complex data and real-world action. Gurobi is the global leader in mathematical optimization, trusted by thousands of companies to solve their most complex problems with speed, precision, and reliability. Whether it's supply chain design, portfolio optimization, workforce scheduling, or integrating optimization into AI pipelines, Gurobi powers the decisions that matter the most. Welcome to the show, Jerry. How's it going?
I'm doing great. Great to be here. Thanks for having me on. I'm excited to chat.
Yeah, this is fantastic. I've heard so much about Gurobi over the years here, and your involvement with them has been nothing but profound from what I've seen, and just the amazing optimizations with math that you guys are able to pull off to help a wide variety of companies and different pursuits, from science and medicine to things like chip manufacturing and resource management and things like that. It's phenomenal. So tell us
Yeah,
about Gurobi and your involvement.
sure. So to talk about Gurobi, take a smidge of a step back to talk just about mathematical optimization as a whole and what that is. So it's mathematical optimization is a prescriptive analytics technique, and I could sort of compare and contrast that with machine learning stuff like that in a little bit. But prescriptive meaning the output is sort of like an action plan. Here's what you should be doing. It's more of a decision sort of making tool, decision making approach, as opposed to pure machine learning, not generative, non-generative, all that stuff. So it essentially, what would you do with an awesome sort of forecast of the future world? Some decisions are just way too complicated, even with, lots of computing power, lots of
Mhm.
experience. There's just some decisions that you can make that are just way too complex to
Mm.
sort of just throw sort of power at it.
Yeah.
So you need to throw some smarts at it as well. That's some algorithms and things like that. So
Hmm.
how can I sort of search that space efficiently? And that's what sort of mathematical optimization does. And what Gurobi does is it's a very small, lightweight sort of library of our special sauce of algorithms to help you
Hmm.
solve those problems. So essentially, the process is like you take a business problem or whatever you're interested in. Someone talks to you about it. You have like sort of you have it written down or something. So you have like some sort of verbal or written problem statement. Translate it into a little bit of math, so an algebraic representation.
Hmm.
Take that algebraic representation, code it up, and then you sort of send it off to a solver like Gurobi, and what pops out is the optimal decision for
Mm.
that original business problem. So we're kind of a small part of that whole process. There's a lot of that, of the, starting from a problem description to solution, but
Mhm.
we're it's a really important part. So what Gurobi does is it's the sort of the best in class sort of commercial option for solving these really complex decision problems.
Right. The optimizer, the Gurobi optimizer is that
It is.
product.
Yeah.
Yeah. And man, it's just there's so much reach with what you and your team are able to do. And it's phenomenal. And a lot more people should know about Gurobi because of this. Because with the things like DeepSeek a few months ago, coming out and showing the world, hey, we can do more with less. And that's the best way to go, is to be efficient and to not just throw more
Exactly.
money and compute at it. Let's brute force our way to the top, everybody. Like that will only work for so long until
Exactly.
you really truly need to break some ground and understand the architecture of things differently. And I know I've spent a fair amount of time within this domain, just personally, with research and things that I build and trying to make things better. And from taking models and going, well, this is too much. I'm going to start from scratch, and have a different approach to that and start with an optimal sort of approach where
Mhm.
I'm not overdoing it. And with so much at-home compute these days and the ability for anyone to take certain open models, smaller models,
Mhm.
run them on our home graphic cards, even our CPUs, and we're
Yeah.
able to get different results, but fine results. I've been able to run about 60 different models at home on a very small card and have a fine time. It's a little slow
Yeah.
sometimes, but you think about the work that went into those distilled models, things like Llama 3.2, very small, very effective. And just where things have gone since last year. It's incredible.
Yeah.
We
Yeah.
really need to, reassess our mathematics along the way and check back in because, hey, you never know what you're missing until you really explore and do the due diligence, right?
Hmm.
And that's what you guys really do over at Gurobi. I found
Hmm.
that like just a wide gamut of reach across different sectors and different areas of focus that you
Yeah.
guys are able to tackle and intelligently manage.
Mhm.
So, could you tell us some examples of some projects and things that Gurobi has been involved with?
So yeah, a lot of so our a lot of our customers, our typical customer, are people who sort of know how to do that. I was talking about like that decision problem and the modeling
Hmm.
and the algebraic representation of a problem and coding. A lot of our people that use Gurobi, they're sort of experts in that part.
Hmm.
And 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 as you're saying, like there's a very wide reach for this type of problem because you may have like from my original description, you might be thinking that's super vague, like
Hmm.
problem description, and you write it in some math and then you code like that's super well that just sort of shows like kind of like the power of this approach is that it is very flexible. So there's people, that use us a lot is done for optimization in like supply chain logistics.
Hmm.
That's sort of like the kind of like a bread and butter type of approach and or problems that are solved. But
Hmm.
so like things like, oh, how do I design my supply chain network so that
Hmm.
I'm making sure that what I produce gets to gets from beginning to end at minimal cost and making sure that
Right.
there's sort of like redundancy or minimal risk and things like that. There's a
Yeah.
bunch of things you can sort of bake in to all that, but sort of supply chain logistics, but there's a lot in scheduling. One of the cool examples that I like to talk about is the National Football League, NFL. They use Gurobi every year to determine their schedule, which is, if you
Whoa.
think about
Huh.
that complex of a problem,
Yeah.
it's massively insane when you think about, okay, I have 32 teams over
Hmm.
18 weeks playing 17 games. Sometimes they're on Thursday, sometimes they're on Sunday in the like early, Sunday mid, Sunday lit, Sunday night, Monday night. Sometimes now you're going into, Germany and Brazil to play games. You're going into Mexico, and all of these sort of things are important things to consider. And then you want to make sure that you create a schedule that gets eyes on TV. Obviously that's what you want, but then
Right.
you need to be fair to the players, you need to be fair to the teams, you need to be fair, so there's just all of this just insane complexity. And
Hmm.
and they were just like a f- before they started using Groby, there's like sitting in a room for months hoping to get a few schedules that work, that just are
Hmm.
actually that like actually fulfill like these basic requirements. And
Right.
now once they decided like, oh, let's use optimization and Gurobi, now they're able to sort of generate thousands, tens of thousands of really good schedules that are sort of have whatever their objective is. I'm
Hmm.
not going to pretend like I know exactly what it is, but whatever it is, it's going to be optimal or near optimal. You can sort of
Hmm.
say, okay, well, maybe if it's not the absolute best,
Hmm.
for ratings or whatever it is, but it's really close. Give me 1,000 schedules that are really, really good. And now
Yeah.
you're choosing from the best of the
Uh-huh.
best as opposed to just
Hmm.
hopefully getting to this.
Yeah,
So
just
yeah,
guessing, spitballing it, right? I mean,
yeah,
this is a so logistics, supply chain management, things like
mhm,
that, scheduling time,
yeah,
these vectors are difficult. This is an engineering problem from the start.
100%.
This is
Yeah,
not, you think high science, you think physics, quantum mechanics, algorithmic, enhancements, but this is tough real life stuff to manage, no matter what. And it's a
exactly.
nightmare when you've sent something somewhere physically. Even at the lowest end, let's say you have a fulfilling company or you create a product and you have to fulfill items for shipping.
Mhm.
There is so much discipline to that part right there, you know.
Yeah,
There's so much to focus on. But when it comes to moving parts and people and schedules and games and things like that, and
yeah,
that's daunting, you know. And we rarely think, oh, mathematics, high mathematics is going to get us out of this, but that's what it is, you
yeah,
know, and that kind of planning. So
yeah.
yeah, that's a lot of moving parts. Definitely require that. So
Exactly, yeah.
yeah.
And power and utilities is another one that
Uh-huh.
is where optimization is it's super crucial. Like it's
Hmm.
if you think about it, you have all these different types of ways of producing energy, and how much do you produce by certain types at certain times to make sure you meet demand, and incorporating things like possible storage and renewable, and making sure that your grid is reliable. That's another massive problem. And
Hmm.
exactly how does that work? How does the power flow? What are, there's physics involved in that as well. So you need
Hmm.
to that's another one where mathematical optimization is becoming more and more popular. And there
Hmm.
are, sort of people who run grids and stuff like that that use Gurobi and use other, or use optimization, and making sure that, prices stay, reasonable and everything, and that people are getting the power that they need. And financial services is another one. Portfolio optimization, super
Hmm.
popular. So
Right.
sort of we just sort of went the gamut of like, hey, let's build a schedule to let's actually manufacture and ship goods at minimal cost, and then but let's
Hmm.
also derive an optimal sort of portfolio and then make sure that people get power. So they're sort of all over the place with like the range of applications there. Because all you really need for mathematical optimization is you need that problem statement, but
Hmm.
within that problem statement, you just need decisions that you can make. You need to know the constraints that,
Hmm.
things that limit you, and what's your
Uh,
objective. Do you want to minimize cost? Do you want to maximize profit? Do you want to maximize fairness? Do you want to minimize sort of, carbon,
uh,
things like that? Do you want to become more sustainable? It's a very, again, a very general sort of set of things that you need in order to use
hmm.
this. And that's why it's so widely applicable, and why it's something that, I think everyone who's got their hands on a keyboard or helping making
Uh,
decisions via hands on a keyboard or something like
right.
that, you have data. Data can tell you so much, and it does answers so many questions, but it can't answer them all. So that's why
Right.
that's sort of why I even like sort of came to Gurobi,
Hmm.
given my background and everything,
Yeah.
was just to make sure that people understood that.
Yeah. You were on location and
Mhm.
Booz Allen Hamilton. And so you've had a wide, you know, range of experience with mathematical optimization and
Mhm.
different systems wide approaches over the
Yeah.
years. You know, you're a senior data scientist now and, you know, have really worked hard to understand all these things and come this way. It's not always just pure math either. This is systems thinking. This is systems theory. This is understanding what goes where to really calculate it.
Yeah.
It's so
Yeah.
daunting. And I mean, I brought this example up a million times before. It's always good though. But you think you have a formula that works in the body of mathematics and science. They think, oh, here's this Rubik's cube, and there's a X amount of permutations. All right, this
Mhm.
huge count of numbers that it could be. And based on our formula, we find that this is this number. These permutes are this number. Well, they had the formula wrong for so many years, they didn't realize that the stationary center cubes that don't move
Mhm.
actually expand the total count, not limit it. That was
Yeah.
counterintuitive at the time, you know, and a real eye opener for math and science.
Mhm.
And so a lot of people don't realize you're not just throwing a an algorithm at these problems or vice versa. It's very much a, you know, adapting and understanding what parts are what. There is no
Exactly.
general approach with this. On
Yeah.
the large, maybe there is, you know, for just decision making and with leadership and things like that. But systems thinking is quite involved with understanding the
Yeah.
environment, understanding the subject matter. So you're good at that.
That
Where you've
is
been.
100% like the crucial capability here is, and what really makes this valuable is understanding your system, understanding your
Mhm.
problem, down to the level of granularity that you need and want to, and everything.
Mhm.
It's incredibly important. But when you get that, then you can then optimize it, and
Right.
that's a really cool
Uh-huh.
thing to be able to have the confidence in your solution.
Hmm.
And And one thing that Gurobi does that some other approaches, be it things like simulation or simulation optimization
Yeah.
or heuristics or things like that,
Hmm.
what Gurobi provides and what mathematical optimization provides is the goal is always what we call a globally optimal solution. So it is the solution that comes out is the best one. There
Hmm.
is nothing, there's no sort of like stochastic searching or anything like that,
Yeah.
such that you may be in the right spot to get something really,
Hmm.
really good. Maybe this
Hmm.
time you do get what the absolute sort of peak of the mountain as opposed to
Hmm.
some other peak that's kind of over
Yeah.
here. But what mathematical optimization does is that's what pops out is the global optimal, and that's when you think about some of these massive problems for big companies where you're spending billions of dollars, and if I'm
Hmm.
able to save 1% of that,
Hmm.
okay,
That's a
that's
big percent.
1% of a massive number is still a pretty
Uh-huh.
massive number.
Right.
So, and when you think about the investment that can go into
Hmm.
creating that savings is
Hmm.
not it's not crazy. You
Hmm.
you're not you don't have to invest significant amount of money into like
Hmm.
hardware and stuff like that. You're not building a quantum computer or
Right.
anything.
Yeah.
It's stuff
That's
that yeah, it's
That's a
easy to
big
get on your
deal.
hands.
That's such a big thing to point out for companies out there, large companies that need this type of work, that really
Yeah.
deserve this type of insight for what they're doing and guidance within it. You don't have to have, massive supercomputers to do
Hmm.
this. You don't have to be on the verge of quantum. You don't. You really it's the hard work is the due diligence,
Hmm.
and not some machine doing all this magic work for you. I
Exactly.
look at what you do and what Gurobi does, and all of our attempts in humanity like this are like sort of like race cars evolving over the years. Back when Shelby would put string,
Mhm.
yarn on the car, and they would see the car going, and they could see the
Yeah.
wind
Yeah.
drag, and you're like, oh, we
Mhm.
finally starting to understand and accept wind drag. And then what was it? Enzo Ferrari was like, we're not planes, we're cars. We just go through the air like a hammer. That was his
That's
philosophy,
yeah.
like a hammer, and that's not
Yeah.
how it worked. And he didn't really want to buy in on the whole aerodynamics, but he
Mhm.
certainly had to. And it's funny where you find savings too, and how these things
Exactly.
line up. It's just like when they were, distilling a model, and a larger, large language model down to something smaller. If you do that wrong,
Hmm.
you might not know till later. It might work just great and then fall out at a certain point, or all of
Yeah.
a sudden you have to prevent overfitting, when it comes to
Hmm.
machine learning and things like that. But on the pure end of things and away from the race cars, but just into the pure math,
Hmm.
what is it that really, I should say, what would be the approach of, let's say, I have a model and I want to cater it to some special need, but I want to utilize more optimization to do this. I don't want to, let's say I use optimization for data management first, for
Hmm.
intelligent cataloging, and things like that. Can you go into that a little bit?
Yeah. Yeah. It's like I think people can use optimization for those types of things. I think
Mhm,
maybe something like managing like your cloud spend
mhm,
would be something that optimization could be super helpful for, and making sure that you're because different things, different resources at different costs at different times.
mhm. Oh
You
yeah.
need output and input at
Mhm,
different times as well. Like, is it crucial that I run this machine learning model at this time of the day,
mhm.
or can I run it at night?
Yeah,
What is
that's
your priority for
mhm,
these things? And when you think about the options that you have for doing something like that, and that also includes like managing your data and stuff like that. All the options that you have just make it again another very complex decision. So instead of navigating that yourself, you sort of give here's all my options,
mhm.
and sort of put that, develop like the mathematical model behind that, and then what can come out is you know, here's when you should be doing this at this time with this resource, and this is how
Mhm.
long it's going to take you, and then this is what your overall cost is going to be, and you can sort of then compare that to a baseline
Mhm.
of what you've been doing. And actually,
Mhm.
we do that internally. We use our own product to manage that type of stuff. Testing and all that sort of stuff. We do that internally. We do that optimally as well.
Yeah.
We're definitely on board with using our own stuff when
Mhm.
we can.
Sounds like the Gurobi optimizer is a real Swiss Army knife in the middle of it all.
It is, yeah.
And then you just sort of bootstrap the informations and different things and constraints that you need to help it calculate what is optimal in this
Mhm.
regard. So that's really exciting. And I think about a lot of the data out there that's floating around and what's significant and what's worth using and how do we prioritize that, for,
Mhm.
what is it, reinforcement learning with human, feedback, things like that. Um, there's a certain part of automation that really requires that optimization
Oh
in
yeah,
the
yeah.
long run.
That's
You have to have it there, or you're going to find out a week later, however many days later of training that all that training was for naught. I can imagine that being a sort of how far do you step in until you pull back and take a look, and how long do you have to analyze something in some cases for it to be clear,
Mhm.
and I'm sure that you have a system to do that, to put all the parts in place. What was the easiest project that was successful using the Gurobi optimizer? And then we could talk about a really difficult one, but what would be a really
Yeah.
easy, straightforward one? Uh,
Yeah, I would say
mhm,
probably anything that is like if you wanted to just sort of like get started with optimization
mhm,
and sort of like low hanging fruit is it's again, this is gonna kind of sound general,
mhm,
but any type of sort of resource allocation, that's an umbrella, that's a pretty wide umbrella, but sort of
mhm.
maybe like mapping people to tasks and things like
Okay.
that, making sure
Yeah.
that people are doing what they need to be doing, what they
Mhm,
can do, but doing it efficiently, making sure that everyone is, sort of like your workforce is
mhm.
staying busy and getting things done and making sure that there's efficiency there. That's probably, sort of that's kind of like a scheduling problem.
Yeah, it
So I'd
is.
say
That's
maybe
right.
basic scheduling would probably be
Mhm,
the easiest thing to start with.
mhm,
We have a bunch of sort of learning examples that as long as you're good with Python, which is our
mhm,
most popular API, but you can use pretty much anything that you want. If you're a C or Java or whatever,
mhm,
you can use Groby. But by and large, lots of people are Python oriented, so we are
mhm,
too. If that's where if you're good with Python, you can get
mhm,
started with learning some basic optimization stuff right
mhm,
off the bat. And one of our super basic problems is you have a group of people who are you have I think it's just a group of like three people or something, and
mhm,
you have a bunch of tasks, and you have like sort of like a weighting of like how good this person would be at this task. So
mhm.
what's the best way how should I assign people to tasks to make sure that we
Mhm.
do the best job overall? That's
Right.
a very sort of
Yeah.
simple, kind of abstract, but very
Mhm.
simple plan or very simple problem.
Mhm.
And it just sort of shows the uh the 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 complexity a little bit there. But yeah, it really sort of shows how simple it is to get started with some of this, but the sort of the power as
Mhm.
well. And one of the other sort of, I guess another simple case would be, I don't know if you can see it, I have my t-shirt, but I'm going to
Mhm.
put this here. There's a little
Uh-huh.
website called
Hey, there we go.
burritooptimizationgame.com.
Uh-huh.
So to put that out there, it's a game that we developed
Mm.
internally to sort of help people understand the complexity of decision making as a whole and why optimization is super helpful. And the game is really easy. You have a map, and on this map, there's a bunch of buildings that have people who want to eat. They want burritos. So your job is to make two types of decisions. One, decide the number of trucks that you want to put out there
Mhm.
on the map to feed people, and where do you put them? So
Yeah.
you have a whole bunch of like sort of fixed locations, and then so you can choose. one truck, two, three, four, five, up to as many as you'd like, but there's a fixed cost for putting a truck out there.
Mm-hmm.
And then there's variable costs for ingredients and stuff like that.
Mm-hmm.
But what's the right balance in order to maximize your profit? And you might think, well, just I'll just throw all these trucks out there and get all the demand. Well,
Mm-hmm.
eventually the number of trucks you're going to throw out there is gonna that cost that I'm talking about is gonna just slash your profit. So you
That's
only
right.
throw a couple out there, you're not getting enough people. So what's the
Mm-hmm.
right balance and where should it be? And you sort of look at that problem and you sort of look at the map. You're like, I can do this, eyeball and stuff like that. Essentially, you just drag the trucks around and it sort of show you what would happen if you leave a truck there. So it's like, okay, this is the number of people I would get.
Mm-hmm.
Okay, and you just keep doing that, and then you think you do that to a point where you're like, okay, if I put trucks here, here, and here, this is the demand I'm going to satisfy. I'm not
Mm-hmm.
getting everybody, but I think I'm getting a lot. That's great. This is as good as I can do because if I throw more out there, I'm
Mm-hmm.
going to just be spending unnecessary money. And
Yeah.
then you click go, and what happens is it takes your solution and calculates, what your profit is. But then it also shoots off to our cloud, solves the problem optimally and shoots it back and compares the two solutions. So it's a game in which you actually technically cannot win. You will lose every time. The best you could do
Mm.
is tie. The best you could do is tie.
Yeah. Yeah.
Uh,
Right.
and and it sort of just shows like the first scenario, people can get what optimal is by eyeing it up and stuff like that. That happens.
Mm-hmm.
Second, third, fourth, fifth, sixth, by the time you're in like the fourth, fifth, and sixth, it's impossible. Like it doesn't happen. Just
Yeah.
because, and it just sort of shows like how people just like, oh yeah, this seems fine to make decisions.
Mm-hmm.
It's not. And it sort
Yeah.
of shows the amount of money that you could be leaving on the table
Uh,
for just sort of what seems to be trivial business problems.
I've seen a lot of this in production for light manufacturing and
Yeah.
people, bodies, times, process flow. So many departments are involved with a product. One person does something to it, another person, affects it, then someone else packages it. And how that happens is it's not always simple, especially when there's multiple factories, multiple supply chains of different sorts coming together. It's orchestration at its finest.
Yeah.
This is a you either have a symphony or it's very discordant. And
That
and it
that's a
sounds
great way
bad.
of describing it.
Yeah,
I really like I'm gonna borrow that. I'm
please.
gonna borrow that.
Yeah,
Like, do
yeah,
you want a symphony or not? That's
yeah.
that's what happens. That's really
Uh-huh.
good.
Right. And I mean, from the smallest to the biggest, I mean, the math is always really solid with this and that,
Mhm.
it and I don't want to get into it because I studied systems theory for the last 25 years, okay? And number theory,
Mhm.
propositional calculus, topographical number theory, all these different things. Built file systems, I study a lot of different types of math, okay? But there's always a limit to what I know, and there's always something daunting that I'm looking at, right?
Yeah.
But in regards to the way this works, it seems very friendly for developers and different people because you're saying, hey, we use Python, you can use some other languages. So explain to everyone and myself, is this like a sort of someone would be using this to kind of make their own dashboard with it so they can see this, or is this something where or do you supply a sort of dashboard through this? How does that work? How would I
Yeah.
engage? Let's say I wanted to optimize for my company,
Mhm.
and I'm a Python user, of course, and so how would I engage Gurobi Optimizer?
Yeah. So the Groby part specifically, like comes toward the end. You'd figure out what your business problem is,
Mhm.
talk to the stakeholders, people that are important, who get everyone in the room and figure it all out and say,
Mhm.
this is the problem, this is our objective. We want to, do something and minimize our costs, but we also want to keep in control, like our carbon emissions or something like that. And
Mhm.
so you sort of come up with your objective. Here's what we're here's all the levers that we can pull, the buttons that we can push. Here's our set of decisions that we can make
Mhm.
that we're interested in. And then here's all of our constraints. We need to make sure that we meet demand. We need to make sure that, these are the different types of ways we can transport goods. And
Mhm.
here's like the amount that, capacity limits and things like that. So you come up with all the things that sort of make it difficult
Yeah.
to just go like this. Like, yep, this is the right decision.
Uh-huh.
But you can't do that because of all these complex business rules and all that sort of
Right.
stuff. So first you figure
Uh-huh.
all that out. And then you sort of take that and then you represent it mathematically. So what I mean by that is typically if you have like a fixed cost plus a variable cost for the
Hmm.
products that you make, then you have some number C plus
Hmm.
X times, C,
Hmm.
capital fixed cost F and a lowercase c or, so it's just your overall cost is F plus XC. Could be your objective. So you're taking that that concept and you're relating it to the algebra. And then same thing, similar things for all the constraints and stuff like that.
Hmm.
You represent it algebraically
Hmm.
and then translate that algebra into code. So you would then download, something you would install Gurobi Pi, which is our Python package,
Hmm.
and then connect that to a license. So there's a bunch of different ways that we do our licensing. You use this in containers. You can just or just on a laptop. You can use our cloud services. You can put it
Hmm.
on your cloud service. Essentially, anywhere that internet exists, which is mostly everywhere, you can
Yeah.
use Gurobi. So
Yeah.
it's an easy way to get access to it. But
Hmm.
essentially, that's all you have to worry about is everything up until that.
Hmm.
Um, Getting the optimal solution is what Gurobi does, and that's what we do. That's what we're the best at, is actually churning through that space that is sort of that comes about from this. And if you sort of think about if you think about like on a two-dimensional surface, you have like your XY axis,
Hmm.
and you just start drawing a bunch of lines and stuff like that. Those represent your constraints and sort of shade in one side of it. What
Hmm.
you get is, like a polygon with a center in it.
Yeah.
That you're trying to find what is the point within there that gives me the best result.
I
And
see.
that's why the math works out so nicely is because there's other sort of mathematical properties like convexity of the set and stuff like that and the
Hmm.
fact that it's linear in most cases.
Hmm.
Um, that's what helps us prove this optimality. And
Right.
and and uh, so that's what Gurobi does is it sifts through that space and says this is the solution. And then
Hmm.
however you need to then display it, that's again up to you. If you're building a dashboard where people can play with parameters, like business users can play with parameters, what if my prices are this? What if my costs are
Hmm.
this? What if my demand it goes up by 10%? You can do all these
Hmm.
what if scenarios and
Yeah.
you sort of build this tool and then you let people play with it. And
Hmm.
that's how actually a lot of people interact with Groby you don't even know.
Right. Right.
If you do any supply chain stuff with SAP, you're
Hmm.
probably using Gurobi and you don't even know it because they're a customer of ours and we're a great partner.
Hmm.
So yeah, there's a lot of companies that if you're using some tool that does some sort of optimization, there's a chance that there could be Gurobi on the back end of it.
Wow.
So you could, and if you want to build that yourself, and we have a lot of consulting partners that do
Hmm.
that, like that's their job is to figure out the beginning part of it, help you with that,
Hmm.
what's your business problem? Let's help you
Hmm.
code it up and then let's
Hmm.
build a tool. And
Yeah.
all of that stuff is all around Gurobi. We're just this little part. You
Uh-huh.
mentioned earlier, race cars and everything like that.
Hmm.
We are the engine.
Hmm.
Everyone else builds the fanciest car and the
Hmm.
best tires that make sure, and everything's super aerodynamic. It's all tested and everything but we are the engine that makes that go as fast as possible.
Right. Wow. Yeah, I bet there's a lot of eye-opening moments with these
Mhm.
companies sometimes. We're like, wow, we had no idea this was a strong point for us. This whole time we thought all these other things were doing it for us, but in fact, it's this little thing over here we're not paying attention to that's really giving us the boost.
Yeah.
There's so many situations where, if you're studying these types of things in systems theory, you're used to the puzzles. And like, okay, here's a real head scratcher. Why is this so opposite of what you think it should be? Why is
Mhm.
this counterintuitive? How is this happening? How are we getting
Yeah.
by? This doesn't make any sense.
Yeah.
And then you find out later. And from working with hardware and software and digital forensics and different things on a very low level, I have
Mhm.
found this to be the case, where all of a sudden you have this finding and it's emerging information and the insight's profound. You're like, wow, this whole time it was this
Mhm.
amazing, and optimization. I mean, this is a big picture power. Okay. This is not just the small end of things. This is the big picture. I
Yeah.
think about mathematical optimization on the small end, as a hardware guy, software guy. I think,
Mhm.
a long time ago, you could take was it the smaller floppy diskette? And we had, because I was in that world of things,
Mhm.
okay, and developing a new way of formatting it, FAT30 or FAT32, in which it actually held more space than a normal floppy could hold, and it was all there
Mhm.
and that was done. We were able to pull
Yeah.
this off, and so I've over time I've built different file systems and things looking for optimizing this or that,
Mhm.
and you'd be surprised what you can do, and so I think it's really important that people who have large companies with lots of moving parts come to
Yeah.
Gurobi for this insight because you don't know what you don't know. Okay.
Exactly.
And
Yeah.
you're going to find out the hard way. You might not find out at all. You might just
Yeah.
go along and never have to worry about it. Good for you. All
Mhm.
right. Not many people can do that these days. But for the rest of us, I think it would be, a good thing, a good priority to seek
Yeah.
out that type of insight. Because if you're saying, oh, let's buy all these things, you're used to just buying the things when it breaks. You're used to just getting the things, replacing the things instead of preventing those things from happening.
Exactly.
Maybe,
Yeah.
look, we're doing this wrong. We're creating way more wear. And all the times we've been looking at this problem like, oh, if the cost of this replacement thing would come down. No. How about you just replace the cost with a different solution altogether and start doing
Mhm.
something differently?
Yeah.
And so I've had to affect systems where someone didn't have a feature on a machine. I would find out how to create that feature, provide them with the information. They would create the feature, and that vendor blew up. And all of a sudden, their 150 websites of advertising have changed, and this feature's been added. And it was like
Mhm.
they didn't even like my request helped create that revenue stream for them. And had I not just pushed the envelope and then figured out how to do it and showed them, that
Yeah.
optimization would have never occurred. And the optimization isn't always this higher speed. Sometimes
Mhm.
it's less resistance giving you the higher speed, not just more horsepower. Okay.
Yeah.
You know what
Yeah.
I mean? Let's throw
Yeah.
more compute at it. No, like you're still gonna hit the wind,
Yeah.
you're gonna be up against that resistance. Okay.
Mhm.
And so minimizing resistance on all the parts is a good reason for optimization.
Yeah.
Even if you cannot project and it feels daunting, you can still optimize within that.
Mhm.
And there's again there I could think of the music analogy and the race car
Yeah.
analogy just really
Yeah.
hit home for me right now because
Yeah.
speed is important, but it isn't everything. It's
Yeah.
like they say, slow and straight equal fast.
Mhm.
Slow, straight, and smooth will equal
Yeah.
fast. You just have to keep that up and build into that,
Yeah.
and that's the thing. I mean, so making it approachable for people, making this understandable is so important. Okay.
Yeah.
And so here
Yeah.
we've done a pretty good job of this today, but let's keep diving in. Now, a bigger project that happened recently is a good example was NVIDIA's open sources cuOpt. Am I saying that
Mhm.
right? CU
Yep.
opt. Okay. And so let's talk about that. It's large scale optimization methods that you
Mhm.
guys used for this, first order methods, I should say.
Yeah.
Can you explain some of that to everyone out
Sure.
there?
Yeah,
Yeah.
so there's from Gurobi side, we work primarily or exclusively on CPUs. We
Hmm.
are the type of math that I was sort of that it needs to be done that I sort of was describing of like churning through this space of possible
Hmm.
decisions is not highly parallelizable. So
Mm.
GPUs just don't do that great.
Yeah.
So we're on a CPU sort of thing, but there's a different and the algorithms that we use just sort of are supported on that, and that's what we've been doing.
Hmm.
Now, there's been sort of newer algorithms. So if you do happen to have experience in mathematical optimization, the
Hmm.
typical algorithms are called the simplex method,
Hmm.
and then barrier is the other. Those are the two ones that are solve what we call linear programs.
Hmm.
And then if you have sort of other more complex constraints that require sort of variables to be yes, no, or to be integer values specifically.
Oh
So you
yeah.
can't have 1.5, but you need to have
Mm-hmm.
one or two. Then
Mm-hmm.
there's other algorithms called branch and bound,
Mm.
and then there's like cutting planes and stuff like that. So there's these
Right.
all these algorithms
Uh-huh.
that work, and those are all really good on CPU, and that's where it works. Now with what's sort of popped up over the last few years, and I believe this is the original was a research paper produced by Google maybe like 4 or 5 years ago.
Mm-hmm.
There's an algorithm called primal dual hybrid gradient,
Mm. Mm-hmm.
PDHG. I,
Okay.
that's why I had a hard time saying it because I never say it. I always say
Right.
PDHG. Anyway,
Yeah.
but yeah, it's a first order method. So it's something that is it's just a very different approach
Mm-hmm.
to what the other algorithms that I was talking about how they work.
Right.
So because of that, it's a different approach. It's something that can actually be more parallelizable.
Mm-hmm.
So because of that, NVIDIA is sort of noticed that, and they are producing sort of their own open source solver that is on GPU,
Mm-hmm.
and it's something that we're really excited to sort of see how it works, to learn from it. We've partnered with NVIDIA to sort of help test it a little
Yeah.
bit. We've done our own internal testing
Mm-hmm.
to sort of see how this is going to change the game. Right now we're sort of cautiously optimistic that it's something that we're going to be able to sort of learn from and work with, and it may be a way to sort of just if you're someone who's heavily invested in GPUs over the last few years, like this may be something that could really be a game changer, really great
Mm-hmm.
way to introduce yourself to optimization because you have very expensive hardware that you
Yeah.
can use for something else that's completely awesome. So,
Yeah.
yeah, so it's a great opportunity,
Mm-hmm.
and we had a uh, great time working with NVIDIA. They actually
Mm-hmm.
if you listen to the keynote for their conference that was about a month ago, Jensen Wang talked a little bit about co-opt and mentioned
Mm-hmm.
Gurobi. So it was a cool little shout out for us.
Yeah.
We're excited about it, and
Uh-huh.
in the future, like we're really excited to sort of keep working with them and sort of
Mm-hmm.
seeing how this develops. Because right now it's in this, we don't know exactly how well it's going to go. How
Yeah.
are we really going to be changing the game
Mm-hmm.
when it comes to optimization? There are a lot of signs pointing to yes in the future. So things that, and this is one of sort of the criticisms of optimization. If you're like, hey, I want to do mathematical optimization, someone might come up to you and be like, oh, I've heard that those problems don't scale well, that they're part of
Mm-hmm.
NP hard or NP complete.
Yes. I was gonna say NP. Yeah. Yeah.
Yeah. So people are going to throw that at you and be like, oh, combinatorial optimization is NP hard problem, so don't even worry about it. Don't you,
Yeah, we've given
you're
up.
just wasting your time.
Yeah, right.
And we're going to yell at you and say, no, no, we are solving massive problems
Mhm.
of these types, and every people are doing it every day. So what we sort of think of this could be is another way to sort of get our message out there,
Mhm.
and sort of people are like, oh well, why don't we just throw more compute at it, throw better computing at it, throw
Mhm.
GPUs at this, and like, well, it doesn't
Yeah.
work. Now we can say
Right.
it does work, and it can
Uh-huh.
get some
Right.
some improvements to a certain set of problems. So it's an exciting thing for us to sort of see how it develops, and we're really happy to sort of keep working with them and see where it goes.
You can innovate in any sector with this. You can innovate everywhere with this. The whole
Yeah.
approach is completely sound to systems theory. Okay.
Hmm.
You think, okay, well, because I have to work with a lot of different hardware and
Hmm.
advise on these types of choices and decisions. So you think, well, GPUs are really great at training models, are
Hmm.
fast, great. But an NPU, neural processing units, they're better at inferencing and running inference. And so they actually have, better performance on that. Use this for
Hmm.
this, use this for that. Okay, great, excellent. And we find these things out later. You don't have to throw a higher speed at it. It's parallel processing in certain ways that will get it done.
Yeah.
And that's fantastic because again, you can innovate in many places you might not expect. But then
Hmm.
there's a lot of finger crossing where you're like really hoping, that we find that next thing, that nugget of truth that's
Yeah.
going to lead to the greater calculations, and to understand that, especially with hardware being what it is these days and things getting smaller, there's a point where you have to, if you don't if you don't optimize, you're actually you're allowing lots of problems to stack up on the side you don't even know about.
That's
And
true.
in different industries, that may vary, of course, but it can be a really big deal. It's just like, you think about optimization. Let's talk about a device. Here's a USB stick. All right, here's some flash storage. Well, if you have a plattered hard drive a long time ago, you have this in the computer and you delete a file, it just erases it from the index. It doesn't actually write zeros over the file,
Hmm.
like in Windows or even Linux, just you have to directly write over that. There's a lot of different operations in all this. So let's see where
Yeah.
I was going with this. Well, you have load leveling in memory management. So if you say, well, here's a chip, here's a USB flash memory, and what happens inside of that is something is kind of amazing where they do automated load leveling. So it's wear leveling. So one part of the chip isn't getting written to a whole bunch of times. Different parts of the chip are getting written to and erased. Okay. And so that level of optimization allows the chip to last for longer. Otherwise, you're just writing and erasing the same part of the paper until finally you've erased a
Oh,
hole
yeah.
in the paper. And that's the analogy I have found over the years to explain to
It's a
clients and companies.
that's a really interesting
Yeah.
yeah, way of putting it. Yeah,
Uh,
what's the best way to do that? That's,
mhm.
it's an interesting problem. Yeah.
Right. And you never know because I mean, for things to work, there must be a certain level of optimization. So
Mhm.
back in CD technology, optical storage medium, a byte is 8 bits. Okay. But in CDs, they have this thing is called 8 to 14-bit modulation or EFM. Okay. And it takes that 8-bit byte and turns it into a 14-bit byte or a Reed Solomon like algorithm to create error correction on the read, okay, on reading,
Cool.
you know.
Yeah.
And so that's you don't think about these kind of things happening, and it happens really fast without you
Mhm.
knowing. A little buffer fills up, you're listening to music in the air, that CD's playing, and there's bumps and scratches on them, but you never hear them because they're below the level of any error loss, right? They're within
Mhm.
that C1, C2 error correction. If it's CU unrecoverable, then you've lost it. You'll hear a little skip.
Mhm.
Okay. Likewise, in hard drives, you'll find that, oh, I've lost data. I've had to do a number of weird things with physical hard drives, including reading in reverse to throw the reader at a different speed from a different place into a location to actually physically get by a rough spot to
Oh,
recover the
geez.
data. I've done these things surgically by hand for years. Okay. But
Mhm.
I think about optimization. I think about, oh, file systems, and how we can take and do more with less, looking at a lot of the experimental languages out there that were used and oh, how can we sneak something in to do something? Oh, here's white space. It's using carriage returns, spaces, tabs, all these different things to create a language on the minimal. So I always think about the smallest possible degree of affecting a
Mhm.
system, from that forensic standpoint. And that's why I was so excited to have you on. I was like, okay, it's time to really nerd out on that because what
That's
we have going on today is super exciting. We had everybody responded to DeepSeek R1 coming out back in
Mhm.
January. An hour after it came out, I got it and started writing agents with it. I was so happy. And my stuff works too. Okay.
Mhm.
And it would not have happened if there had not have been a larger model to distill from. It's not like they just
Yeah.
started out of the gate. We're going to make something great, small from scratch. It
Mhm.
wasn't like that. It was built on the backs of these giants, literally. And as we go, as we keep refining, we're finding out, we can either take from what we have found before or we discover something completely new that shakes it up. That's
Yeah.
what's so exciting to me about what Gurobi does is that you give companies the ability to find new insight into not
Mhm.
just what they have, but in what they really could be doing with it.
Yeah.
A lot of times I have done this so many times over the years for one company I was with for like 18 years. And through that company, I helped reach a lot of other projects, a lot of larger companies from medical, to security, to cybersecurity and things like that.
Mhm.
And where it's critical. These are mission critical operations.
Yeah.
This is not for fun. This isn't just some video music project, vanity press, what have you. This is, and not just software, but it's critical software,
Hmm.
not just brand protection, but human life protection, this is
Yeah.
critical. And so to me, this is everything. I think that if you're a data science, if you're a, aspiring data scientist, that you need to follow what Gurobi does to a
Hmm.
T. You need to read about it, study it, understand the nature of what they're doing. I heard about you guys last year, maybe even longer ago, through our friend John
Oh
Crone
yeah.
over there, And so once I started hearing the name, I was like, hey, you know what? This is incredible. And so much was going on at the time with the small models coming out. In fact,
Hmm.
that's what it was. Like Llama, was making a lot of the smaller ones and 8 GB size models, and things like that. And I was just like, okay, everybody, here's where it's happening. And I had a lot of friends and cohorts at MIT who they had projects that they really didn't think would be affordable after a while because of all the token costs, right?
Yeah.
Who knows how long it's going to take to train this, whatever. They had a very hard time understanding some of these things, and we all were wondering. It wasn't about them, it was about the world around us, really. But at the end of it all, we find that, oh, yeah, there's a way of doing it, and it's better and it's smarter. Let's do that. And then all of a sudden, after DeepSeek came out, all these people started coming to me, hey, let's talk about those projects again. I think we can really do it. We can
Hmm.
afford to do it now. Optimization's
Yeah.
happening here. And so to me, that's a big deal. It provides opportunity and it makes things that were hard to approach approachable and possible.
Hmm.
You know what I mean?
Yeah.
Because
I
for
agree.
one reason or another, the constraints are such that we don't have room for this. Well, how could we cater to the need, more
Yeah.
effectively? And that's what you do there.
Hmm.
And also what the emerging discoveries along the way to me are gold. Like we had no idea that XYZ vector of our operations was actually a clear winner the whole time. We weren't able to see its performance. It was so quietly just doing what it did and it never stuck out. And we found out that, it's like when it comes to smaller businesses, SMBs, and people who find out, wow, we were getting a lot of customers from this and we had no idea. Let's optimize
Hmm.
our web exposure a certain way. You know what I mean?
Yeah.
It's not all about like some algorithm. The algorithmic approach derives quality and efficiency, but it's not for the sake of the algorithm itself. So you don't have to be involved in a company that's high science and math, physics, or what have you. Just the whole supply chain question, just
Yeah.
the remediation of where, when, why, how, who's doing this, what can we bring into the picture, what should we, kind of augment, this is
Mhm.
key. So no matter who you're working with or for, Gurobi probably has some involvement that would really stand to benefit everyone there. So let's see.
Yeah.
So so no special need for hardware or software for anybody out there. You're providing a Python package, on the
Right.
large for people to utilize, and then that connects in an authenticated way.
Yeah.
Like I guess is some type of API key or something that you guys use to do
Yeah.
this. And so anybody's on a laptop and they're engaging with your systems, which have some compute. Does Gurobi have a,
We do.
what's on the back end of Gurobi that's helping people do this?
Yeah.
If you could talk about that, yeah.
We do have our own sort of cloud infrastructure that you can utilize and
Hmm.
use for computation. But then not a lot of people do that, but when it's needed, it's extremely helpful
Oh yeah.
to some of our customers.
Hmm.
By and large, most people, use their own cloud, stuff,
Yeah.
and however you do any work, Groby can still
Hmm.
work there. And so I'm sort of, again, kind of being vague. It's because we work where you work. Um,
Hmm.
so and so any type of VMs that you want to sort of spin up and anything like that, then you
Hmm.
can use Groby on that. We make sure that
Yeah.
that works seamlessly. We have
Uh-huh.
like our licensing is built for use online like that.
Hmm.
But then at the same time, if you just want to uh, get a license yourself and mess
Hmm.
and use it on your laptop, you certainly can.
Hmm. Right.
Um, and that's all for like development and
Hmm.
production and stuff like
Hmm.
that. You sort of mentioned like, hey, if I'm a data scientist, I need to learn how to do this.
Hmm.
If you pip install Gurobi Pi right now,
Hmm.
then you get it's a very, very limited license, but it's still a free license for
Yeah.
learning purposes.
Uh-huh.
So all of our like notebooks that we put out
Mhm.
there, which part of my job at Gurobi is to put these things out there so data
Yeah.
scientists can learn,
Hmm.
and do trainings and all that sort of stuff. All of that
Right.
is, you don't need a license. You don't need to call us up and say, "Hey, I want to learn how to use Gurobi. Give me
Hmm.
can I have a license?" Um, you can just do that right now with
Hmm.
it. So this is really lowering the barrier to entry.
Yeah.
So just hop on our notebooks and start
Uh-huh.
learning. Go to our training stuff that's on YouTube and stuff.
Yeah.
If you go to our YouTube, Groby's YouTube channel, if you really like listening to me talk, which
Uh-huh.
I don't know everybody would, but you could listen to me talk for a long time because
Yeah.
I have two sort of 2 8-hour trainings are on there. So you
Hmm.
can start, and it's something that's geared towards data scientists. Like, so if
Hmm.
you're a data science person or just any analytics person
Hmm.
or any engineer, anything that's not, someone who already knows optimization, then it's a great entry point. So everyone can learn this sort of right out of the
Hmm.
gate. As long as you're good with Python, all that stuff will work. And it'll
Yeah.
be great. It's just a great way to get learning.
Oh.
So yeah, we make it easy,
Hmm.
and that's a big thing for
Yeah.
me is making optimization approachable,
Uh-huh.
learnable, and
Right.
something that people can do, because data scientists and now I guess you can say AI engineers, whatever
Yeah.
title you want to,
It's all data.
lump on yourself. Some of the most dedicated, self-taught people
Hmm.
that I've ever come across. Like the ability to say, this is a problem that I'm interested in, I want to solve, and have like this motivation to learn and then tackle the problem and then say, okay, now I'm so much better at this. Like
Hmm.
I feel super confident that
Oh,
most
yeah.
people would be able to pick up mathematical optimization. Obviously it'll take time to be an expert, but that's
Oh,
true of
sure. That's
anything and
everything.
everything.
Yeah. Yeah.
So, but that shouldn't scare you off.
Yeah.
And to sort of toot our own Gurobi horn a little bit
Uh-huh.
here, is even if you're not the best at modeling stuff, and there
Hmm.
are right ways to build a mathematical model, and there
That's
are
right.
wrong ways, and there
Hmm.
are good
Yes.
ways, and there are not so good
Hmm.
ways. And there,
Yep.
so
Yep.
there
Hmm.
is learning that has to happen there. But
Hmm.
our solver, like our engine, we feel is
Hmm.
so good that it makes up for some of that. So
Yeah.
even if you're not great at it,
Uh-huh.
that's fine. And you want
Yeah.
to actually put stuff in production, and you actually want to make decisions, you want to use
Uh-huh.
this, and you're not a super expert, that's perfectly
Yeah.
fine. You can
Right.
still solve really big problems
Uh-huh.
very efficiently. Some of our customers use stuff real time. Like they are like, I have all of these orders. How do I ship stuff out? I need to make this decision right now. And
Uh-huh.
they're doing that type of stuff. A couple cool customers that we like to sort of talk about. Lyft uses
Oh,
us for
yeah.
stuff like that,
Hmm.
and Instacart
Oh,
is so how do
makes
I
sense.
match
Hmm.
people's grocery orders or sort of restaurant orders in Instacart? How do I match that to the right person at the right time to make sure that you're
Hmm.
getting your stuff within the time frame that you want it, and not 3 days from now,
Yeah.
stuff like
Yeah.
that. So that's a very complex optimization
Uh-huh.
problem, and so those types of sort of real-time decisions are things that you can do with mathematical
Hmm.
optimization. And then you can also do like this planning, like I want to build a schedule for for the next quarter of my processes or something like that.
Yeah.
That's a
Yeah.
much more strategic view,
Hmm.
and that's perfectly fine.
Yeah.
So there's different ways, different sort of
Hmm.
sort of levels of granularity and
Hmm.
time frames that you can use optimization for. So it's, again, not just like sort of this industry sort of
Hmm.
agnostic thing, but it's,
Right.
sort of, I guess, time sensitivity or
Right.
planning horizon type of stuff. You can do it all over, real time to not real time.
You
It
guys
sort
help.
of spans everything.
So, it's mathematics and, technical conundrums like this are their own gatekeeper. And I think that it's hard to approach no matter who
It
you are
is.
sometimes. And so it's important that Gurobi makes it approachable
Mhm.
and makes this level of education accessible. Like you said, you have these videos on YouTube, and I
Hmm.
can go to the good old YouTube University and learn, right?
Yeah,
I
yeah.
think that's really important that people see these. I'll make sure that they go into the article and that other data
Hmm.
scientists have access to this
Cool,
because it's
cool.
incredibly important. And again, you find out things along the way that you never would have seen before
Hmm.
in this approach. That's why I recommend it to every company out there is to really take a firm look at this in light of what you don't know as a discovery effort, not, okay, we're going to use this to fix something and improve it. Now, use it to discover what you have. Use it to understand and map what you have. You'd be surprised at your assets sometimes.
Exactly, yeah.
It's getting what it's worth out of what you have that's so important. It's like not chewing your food all the way, right? Let's
Yeah,
optimize that meal by chewing your food all the way and getting all the calories and nutrients out of it.
yeah, yeah.
I feel like a lot of companies they skip over these types of things in
They
an
do.
effort of what really just, and it's no one's fault in particular. Sometimes it's just a matter the culture of
Yeah.
looking at it like that, the culture of just faster. Look at race cars. It's like Enzo Ferrari. Again, I don't need aerodynamics. I go through the air like a hammer, you know? That's what he said. But that's not how it works. And we have to look at
Hmm.
these other things, you know? And sometimes taking something away can add to it. You know what I mean?
It's
Less
very
is
true.
more when
Yeah.
the take away that resistance and you gain
Mhm.
you're adding speed by taking away weight, you know, and
Yeah.
not by adding horsepower in some cases, you know. And so this is really incredible. So let's see. So how does this affect the open source
Mhm.
communities or any type of in any way, shape, or form?
Yeah.
What? Let's
So
talk about that for a minute.
you can you can do mathematical optimization with a bunch of open source packages,
Hmm.
and I highly encourage you to start there. I think that's a great place to start too. You can
Hmm.
start with Gurobi Pi and all that sort of stuff
Hmm.
as well, and get our trial license and everything like that.
Hmm.
That's great. But also start with open source. Um,
Hmm.
I think it because my main mission is to get more people to use mathematical optimization.
Yes.
And at some point, then you may think that Groby's the right tool for you. Great,
Hmm.
cool. Thumbs up for that. But if not, I still consider that a win for me because
Hmm.
more people are using a technique for problem solving that I think is
Hmm.
super underutilized. Open source, yeah. So do open source,
Hmm.
but the problem is, and this is sort of why Gurobi is a commercial product that you have to buy,
Hmm.
is because when you think about where the value is in machine learning and now
Hmm.
LLMs and everything, the value is in the data. That's where the fights
Yes.
are over. That's what you pay for. That's what you
Hmm.
pay people to clean and everything. All of that value, the data is what's valuable. The actual mathematical algorithms that sort of solve that fit the models and everything,
Hmm.
not super complicated.
No.
All the, gradient descent is something that everyone that a lot of people learn how to code. That's like one of the first that was
First,
like one of
yeah.
the first algorithms I learned to code
Uh-huh.
in,
Right.
college and everything like
That's the
that.
first
So
one I optimized was that. That's the
yeah.
first one I actually approached optimizing and got some gain on too. So we all remember the perceptron, right? So
Yeah.
let's write some numbers.
Yeah.
But
So
yeah.
yeah, so that's so the machine learning and all that, the values in the data.
Hmm.
For mathematical optimization, the value is in the algorithms that churn through and solve the problem, the complex problem that you're trying to solve.
Right.
And that is something that just open source stuff is what people have donated their time. It's
Hmm.
something that's not maintained necessarily all that
Hmm.
well.
Yeah.
It's a great tool to get started, but when you
Hmm.
actually get to problems that really impact your businesses and stuff like that, then you're probably going to need something that has a little bit more power to it. So
Yeah.
here's a case where power is important, but it's
Hmm.
power via algorithm, power via smarts, not just pure computing power.
Yeah.
Um, so so I highly think that, open source is a great place to start, but what an issue is that people will sort of come across mathematical optimization and like, oh, okay, linear programming, that seems really cool. I can do some stuff there,
Hmm.
and then they quickly hit like a limit of what open source can do. So then they think,
Hmm.
oh, since open source failed, I use open source for everything. So that means optimization fails. So I
Hmm.
discard it as a technique that I can use. So then I just sort of move on to something completely else. I need to use, sort of heuristics. I need to build things myself. I need to
Hmm.
do all that stuff. And they don't make the jump to say, okay, well, is it worth me paying money, buying a license to actually get the power that I need to get the smarts that I need to solve the problem at the
Hmm.
scale that I want? So that's
Right.
kind of an issue for
Hmm.
us because we have plenty of people who switch. I think actually, of the percentage of people who switched to Gurobi last year, I think over half of them were from open source solvers.
Hmm.
Open
Yeah.
source and we get a lot of people who use Excel solver as well.
Yeah.
There's a
Yeah.
solver built in there that can
Uh-huh.
actually, that's a great place again to learn the structure of optimization and how it all works together.
Hmm.
And it's a great place to learn and great place to get going. So highly recommend that. But again, at some
Hmm.
point you're gonna run into a brick wall. It's gonna come fast.
Hmm.
Like it's gonna work
Right.
great, work great, work great.
Yeah.
And then all of a sudden it's gonna just crap out on you.
Uh-huh.
And at that point, then
Uh-huh.
maybe it's worth giving Gurobi a call and saying, hey,
Right.
I have this model and stuff like that. I've worked through
Uh-huh.
it. And at that point, we give out free evaluations.
Sure.
Um, so you can use our product for
Right.
30 days. If you need more time, we're pretty cool
Uh-huh.
about that too. And what I really want to emphasize that is you made all this effort to maybe learn optimization
Hmm.
and you built these models and you did all this sort of stuff. You translated your business problem and all that, and then like, okay, you need a commercial grade solver. You call us up, and we're not just going to hand you a license and say good luck.
Yeah. Yeah.
Good luck, have fun.
Yeah.
Hopefully it works for you. If not,
Yeah.
what you get access to, where what you don't get with other commercial solvers, is you get access to our experts,
Hmm.
people who have been doing this for decades. Um,
Yes.
we have like a corporate slide deck or something like that that we send
Hmm.
out to people, and there was a great number on it that I really loved, and it said our expert teams, the super smart math people that we have
Hmm.
over 1,000 years of optimization experience
Oh yeah.
combined throughout everyone. So,
Hmm.
and actually, and going back in history a little bit, our company, the name Gurobi is the first two letters of the names of our three founders.
Hmm.
Um, they came from another company that IBM bought called Cplex, and
Mm.
the person who founded that company was still one of our founders. So
Ah,
so
okay.
our company, even though we've only been around since 2008, Gurobi specifically,
Hmm.
the people that made our company are the people who made mathematical optimization usable by companies at a
Yeah.
large scale. Like so,
Right.
essentially, there's no real better place to start
Hmm. No, not at
than
all.
with so essentially at some point you may come to the grips that that you need a commercial grade solver, and then we
Hmm.
hope that you call us up at that point.
Yeah. I would consider you at the top right-hand corner of the leaders block in that
Yeah.
and that matrix, your Gartner matrix there. You guys are up
Mhm.
there. And again, you make it very inviting and very approachable.
Mhm.
It's commendable work. I mean, again, it's super exciting. At first, it's a lot of math and stuff, but
It is.
honestly, like there's so much to find out. Okay, and I come up with case examples all the time and things that I'm living with right now that would be a good example. Like okay, let's spell one out for a modern company today. You're a mid-sized to large business. And you are questioning whether you need to deploy cloud AI services and leverage that with your on-prem compute AI. Now, why would you need the difference? Well, we need to have security and we need sovereignty and we need a sectioned off, a branch here. We don't
Mhm.
want this exposed. We can't have anything going out. We can use these tools out here on the web for certain things and these APIs by various big players, but we
Mhm.
cannot risk company data going through that a certain way if it's a certain level. How best can we optimize our usage of cloud uh, compute and on-prem? There's a question.
Yeah.
And I'm seeing this for a lot of things, and I'll bring this up. I'm a part of Quai, AI. They're in California. We have over 800 members. We're a nonprofit organization for creating sovereign and democratized AI, where the individuals are in control of their data.
Ah,
This leads to
yes,
digital twins
yes.
and things like this. But what we're doing is we actually have distributed computing through all of our nodes in such a way that's like SETI, like search for extraterrestrial intelligence back in the day,
Awesome.
but it's Intel's actually given us money to do this. But we're using a variety of hardware. You can use at-home hardware and run a node and be a part of that whole system. And as you contribute, people can use your hardware and you gain tokens. And it's sort of like Bitcoin in a way, I guess. You know, there's some
Okay.
payoff for people. But it's really amazing because if you look at it in a place that's getting new infrastructure that needs it, you have citizens, you have students, okay, right? But then you have municipalities like hospitals, power companies, and then you have the government level stuff. You have these tiers of security going up the way. And how best can we manage this? And how best can we take a distributed computing system and then we want to optimize when we're throttling it. We want to give all the nighttime use to the universities and stuff to do their big training for their models. But in the daytime, we want to have these peak hours available for everybody's normal traffic use. How do we manage that? And these are the puzzles I'm facing right now in other countries with what
Ah,
I'm doing. And I'm seeing this play out. And being a part of the open source community here in Seattle, I
mhm.
was part of the Seattle Greater Linux Users Group. Shout out to G Slug. That was in 2001, it's what, 24 years later. But all down the coast, we've had at the West Coast, we've had so many amazing open source projects. And I know you're in Oregon. A lot of my people are in California. I'm up here in Seattle, and from the Seattle Wireless Project to the LA Mesh Network project that was going on, we have so many parallels and so much good people putting in good work and heart into this stuff to see it happen. But
That's
how can
awesome.
we how can we optimize this thing where, there's a point where people who are doing things for charity will turn over and come right to Gurobi and get funding and actually use Gurobi to do a bigger project. Okay. And it's
Mhm.
so important. I make sure a lot more people see you too because of this,
Great.
because
Great.
it's just so important. And like I said, I've spent a fair amount of time attempting to, okay, optimize certain things,
Mhm.
within my programs and stuff. And a lot of what I've learned is just build from scratch and
Mhm.
build better and start finding the harmonics and start finding that rhythm and
Mhm.
that pace of things to see how things flow and to understand that what you're optimizing, you've been trying to optimize a bad idea of something. It doesn't work the way you thought. And sometimes
Yeah, yeah.
optimization brings you to the water to show
Mhm.
you what's really there, to really
Yeah.
define the constraints and define the environmental scope.
Yeah,
It's
it
so important.
makes you take a hard look at yourself in a sense.
Hmm.
Yeah,
Right.
which is
Yeah.
important. And
Uh-huh.
yeah.
Definitely.
Yeah, one thing
Yes.
that you mentioned a couple times is like the counterintuitive nature of like what you can get when you do when you do optimization is like, well, this doesn't make sense.
Hmm.
I sort of just I say mathematical optimization is the best cheater of all time
Hmm.
because it will if you give it any loophole to sort of figure out, something, it, it it'll find that loophole. It'll find a way to cheat
Hmm.
and give you a solution that just makes no sense. And it really makes, and if you get a solution that makes no sense, it's not the solver's fault.
No.
You need to improve your model to make it more
Yeah.
realistic.
Right.
So it
Right.
helps you understand where gaps may be or something like
Uh-huh.
that, or like things that you don't
Yeah.
understand properly. So it
Right.
really does help you sort of
Uh-huh.
understand your systems that you're trying to optimize or you're trying to improve. It really does help you do that
Yeah.
by giving you weird and wonky answers like this is not possible. Why is that not possible?
Uh-huh.
Because of this. Oh, now I understand my
Yeah.
problem a little bit more. And now you
Right.
learn something in addition. So
Uh-huh.
it's a cool thing that it helps
Hmm.
you sort of understand.
Right. And, we're doing this to approach certainty, and a lot of times you don't realize why something's doing something. We might mislabel ambiguity as a bad thing when it's actually a strength to have
Oh yeah.
ambiguity in a certain place. And
Hmm.
in some places, ambiguity is bad because it can mean a bit's in the wrong place or we have to error correct something, but sometimes ambiguity can be the multiplicity of an asset and its ability to do both things at
Yeah,
different times, and that's a strength.
it is.
And so it's important. There's a light in the dark. I think this also speaks to explainability.
Hmm.
I realize that the black box nature of LLMs and the way they work
Hmm.
and inference is an it's an unfolding, evolving approach right now. We're getting closer to explainability through a variety of avenues.
Hmm.
But overall, when you look at a system, any system, explainability is crucial. Uh, and not just in the real mysteries we've created with AI, but
Yeah.
the overall larger physics and larger just even societal,
Hmm.
mysteries that are here. It's all logistics, it's all resource, it's all timing, it's all rhythm. Again, a
Yeah.
symphony can be harmonious or it can all fall apart at a certain point. So that's just so important, especially with things coming out right now with quantum computing where people are making wild claims. Okay. Oh, we've
Yeah.
optimized this. Oh, it would take Yoda years, 60,000 Yoda years. That's a
Oh, yeah.
septillion, a septillion
Oh, yeah.
years.
Hmm.
Septillion years is 10 to the 24th power.
Hmm.
It's going to take 60,000 of those. That's how long the electron lasts or something like that.
Yeah.
Or, it's like, come on, let's boil it down, guys. Okay. But
That's
with all the quantum
yeah.
stuff coming out now,
Hmm.
these are topics of conversation that are ending up in a lot of people's lives, and for one degree or another, it's
Yeah.
just like a week later you'll find out someone's claims were not really material enough, or they were, yeah, okay, yeah, you've
Yeah.
given yourself a weird ruler to measure against. They're
Hmm.
like, we're better than
And
the whole universe of time, and this thing, okay, like, come on, all right, that's a bold claim. I
yeah.
don't know who's
And
going to be around to verify it.
yeah, and quantum's another, sort of talking like about how open source kind of undersells some things, and and
Hmm.
you may give up on open source, and then you may think, all right, let's say that you tried optimization with open source and it fails, and you think I need
Hmm.
more power, and then, well, okay, I know quantum computing is supposed to be telling me that it's like going to be the most powerful thing, and quantum optimization is a massive thing. People
Hmm.
are holding out and not doing optimization now because they think the problems again are so hard that it can
Hmm.
only be done by quantum. And maybe
Uh-huh.
one day in the future, there will be a quantum advantage
Hmm.
generally over
Yeah.
for optimization problems, but it's not
Hmm.
today. And I don't
Mm-mm.
know about you,
No.
but I like to save money today.
Hmm.
I don't want
Right,
to
right.
wait
Well,
10 years.
yeah, there's so much power in this. So let's give people some perspective. Now, back in the day, you had before the existence of the number zero, okay,
Mhm.
that symbol. We counted in a variety of ways. You had the 12s. You count on the sections of the fingers, and
Oh, yeah, yeah.
4 times 3 is 12. It's a
Mhm.
Sumerian, right? But the abacus, we're counting. We're taking away little physical things, or making tallies and stuff.
Mhm.
But it wasn't until there were sort of contests between the on the Silk Road between Western, trade and Eastern trade, and they started having how many transactions can we make occur as merchants, and then
Yeah.
what one was the number zero. Okay.
Yep.
And Charles Seif wrote this book, The Biography of a Dangerous Idea, Zero. I highly recommend it to everyone out there.
Wait,
You
wait.
have it?
I literally have it right here. I know I got
Yes.
blurry background. There it
Then you
is.
know. Okay,
It's
great. Yeah,
it's yeah, it's
we could probably have a
within
handful
arm's
of books.
distance of me at all times.
Yeah, I've got fuzzy logic. I've got perspectives on general systems theory. I got eternal golden braid, Escher Gödel Bach. I have a whole lot of this in my life,
Mhm.
man, and I study constantly. But it's amazing because here we've created all we did was add a symbol. There was no computer involved, but
Yeah.
human intelligence to say, oh, the way we use this symbol just revolutionized everything. Now we're
Mhm.
doing math so much faster. Now here's where I come into with my argument, which is a new language of math,
Mhm.
a few new symbols that have been lacking, interoperability where it matters. Okay, that ambiguity becoming useful again. This thing can be
Okay.
both. It can be
Yeah.
an operator or an operand.
Mhm.
Okay, there's a lot of things like that, and as computer programming languages have evolved, we've become more succinct and more um, you know, verbose about exactly what it does. We're spelling it
Mhm.
out. Now we're talking to computers. Hey, I'm going to vibe code. I'm going to I
Yeah.
was doing that a year and a half ago, and I never would have
Mhm.
called it that. I would have called it being lazy, but or
Yeah.
failing faster. But anyway, I learned a lot from it, and it's got me where I am now, to some degree with
Mhm.
some of my developments. But again, when it comes to this approach, like you said, there's a lot of people want to wait until quantum solves it. Let's
Mhm.
wait till some real technology. And it's lazy. It's not
Yeah.
lazy thinking because you're not thinking. You're
Yeah.
just excusing. It's very aggressive excusing, not.
Yeah. No,
You know what I
that's
mean? And
true.
so I think it's approachable. I think that's why I'm excited as an innovator to sit down at
Mhm.
home on home hardware and with open source tooling and my own, knowledge and what
Yeah.
I think I know at least, and sit down and hammer something out that surprises me and surprises others. And
Hmm.
lo and behold, I do something new. And I've done things that, I've had those small victories where it's like, wow, I did something engineering wise I never would have guessed. And
Hmm.
if I had not just been doing the thing and trying it, I would have never got there.
Yeah.
So let this be a light in the dark to everyone out there that mathematical optimization is not just important, but it's an exciting avenue of pursuit where what you learn might not just surprise you, but could change your world and other
Hmm.
people's as well. So this is a bigger level of participation that we have in humanity where we can approach this, we could all come to this water and drink, and share that
Yeah.
that wealth because again, like it's more sustainable, it's having a better day. Everybody has a better day when things are optimized in a certain
Hmm.
way, and that can be a beautiful symphony, more
Yeah.
than not. We just have to get used to thinking outside, not, I won't say outside of the box, but just be expansive and be in discovery mode where you can kind of forget what you know and embrace the Zen beginner's mind. Okay, which is
Exactly.
to throw
Exactly.
out all the complicated things and just start asking those basic questions again. In martial arts, we call this acronym FASP, FASP, form, accuracy, speed, and power. Okay. And it's just like a race car going slow, straight, and smooth
Yeah.
equals fast, right? And so if you keep coming back to the basics, you keep coming back to the elementary form of it, and then you can work on your accuracy, and then you can actually do that faster, and then you can produce more power behind it, and then you
Hmm.
come back to form and you revisit this is the cycle of learning. This is our developmental cycle in life and learning. Also, I'd like to show that, with Gurobi's approach and what you guys do, look at nature and look at, I had a show a while back I did. It was talking about slime molds and talking about, mycelium networks and how that machine learning happens, how those neural networks
Okay.
learn, how that optimization occurs, and how
Hmm.
that's a very natural process. And so when I see Gurobi, I think nature's way. I don't think a bunch of complex math. I think, oh, we're really refining ourselves to the sophistication of nature's level of interoperability.
Well, that's
That to
cool.
me
I
is
like it.
exciting. It's
Yeah.
so exciting. And so what are some, you know, things that you could leave everyone with today because we're going to make sure I share your educational
Hmm.
outreach, okay, on YouTube and a lot of the
Yeah.
introductory approaches to this, also the site of course and the tooling,
Hmm.
and that library that you guys have in Python. What are some other things that you'd like to bring up here before we close out today?
Sure. I mean, I think the main thing that I just want to emphasize again is you know there's so much emphasis, so much sort of screaming from the top of the mountains, over the last, say 10, 15 years,
Hmm.
10, 15 years ago, machine learning and then deep learning and all that stuff was like, these are the things that you need to do. They sucked all the sort of analytics oxygen out of the room,
Hmm.
not room for much else. Now it's LLMs, now it's generative AI. Like now that's what's sucking all the oxygen and sucking out everyone's budgets too, right?
Yes.
Everyone's
Yes.
spending all of their
Hmm.
money doing all this sort of stuff. And those things do what they do very well.
Hmm.
And so do not, I'm never in no way saying that you should abandon anything that you're working on there.
Hmm. Right.
But what Gurobi does and what mathematical optimization does is it does what it does the best,
Hmm.
So
Right.
and that is a massive set of problems out there that does something different. Again, it's
Hmm.
machine learning is you're predicting the future, hopefully.
That's right.
Same thing for, generative AI, you're predicting
Hmm.
token, predicting the next token and everything like that.
That's
And
right.
you're trying to create the content
Hmm.
based off of context and all that sort of stuff. Again, it's
Yeah.
a prediction model though.
Uh-huh.
How are you making decisions? How is this helping you make crucial decisions for,
Uh-huh.
businesses and everything? It's a very different problem. Prescriptive
Hmm.
versus predictive.
Hmm. Yeah.
Prescriptive is optimization. Predictive is everything else. So they're just two
That's
different things. So
right.
I just want to make it's like if you're trying to find like the motivation and
Mm-hmm.
why should I be doing this?
Hmm.
that's the reason right there is
Yeah.
it's just a completely different class of problems. And I can't remember the original person who came up with that, but there's like the curve of like complexity and business
Hmm.
value, and you start with your descriptive analytics. And okay, that's easy and it gives you a little bit of value, but it's super easy. And then predictive is more sophisticated, gives you more value, and then prescriptive is right up there. Like that's where
Hmm.
optimization sits. It gives you it provides this massive amount of value, and it is complex. It's not easy.
Hmm.
Not gonna say everyone's gonna be an expert after
That's
listening
right.
to me talk for four
Hmm.
more hours or 8 more hours or anything like
Hmm.
that. But it's something that everybody who is working with data and making decisions with it
Hmm.
needs to be something that they're aware of.
Yeah, you're taking
Whether
out guesswork and you're
yeah,
actually creating a possibility of deduction
hmm
where normally it was a projection, okay, or an inference.
exactly.
You're actually able to create a situation where we are deducing facts
Mhm. Yeah,
in a well-defined environment, and that the constraints are such that they can be validated and
yeah,
can be
hmm
explained. Because right now we need that. We need more explainability. We need more effective everything to save
hmm
money for all reasons. Okay, for just all
yeah,
reasons. I like that just because we can be better, let's be better is one of my takes on things. Is let's just
yeah,
can't just is there anything wrong with just overachieving constantly? Can't we just do that? All right,
yeah,
and so, but to me, this is important for a
yeah.
lot of levels. I want to apply Jerobe's approach to what I'm doing. I want to get it. I want to get the library so I can work with it with my memory
hmm
optimization techniques and things like
Yeah.
that I'm working with neuroscience. And so I'm thinking to myself, okay, Jerobi, you've made it in. You're going to be on my computer this weekend. So
Cool, cool.
this is just a phenomenal, just a
Yeah.
windfall of knowledge. But again, creating certainty where there is doubt. Creating
hmm
insight where there was none, giving the
Exactly.
ability to actually forecast where we were just guessing is
hmm
an intelligent step forward on all fronts.
hmm
And this level of optimization is it needs to be up
hmm
on blast a lot more these days, okay? And I think that everybody woke up with DeepSeek, a few months ago. It's like, wow,
Yeah.
we really need to reconsider everything. And everybody else came out with their versions too and
Yeah.
started, redoing things. That's
Yeah.
that's how innovation should unfold. It should be a wildfire of inspiration across all of us
hmm
who are involved. And
Yeah.
so, man, look, I can't thank you enough for coming out. I'm gonna have to have you on again at some
Cool.
point. Maybe you'll help me
Yeah.
co-host and we can really drill some physicists on some of these things
Cool.
too, because I've got those people coming to me for
Yeah.
a lot of reasons. But
hmm
anyways, this is phenomenal. So thank you so much, Jerry.
hmm
And I'm just so excited to take a deeper dive myself into a lot of the tooling that Jerobi has and the optimizer.
Cool.
So
Mhm.
again, thank you so much, Jerry. This is the AI Think Tank podcast. I'm Dan Wilson, and we'll be seeing you all again soon. Thank you so much, and have a wonderful day.